In this quiz and another quiz next week, we are going to be doing load tracing through this building here. This is actually a problem out of our book, and if you look at this problem in the book, all he shows you is this, whatever this is, front view here, side view, and he gives you these numbers and he says, trace the loads. And I thought, oh my gosh, that is probably not enough information. So I drew a building here in AutoCAD using AutoCAD's old-timey 3D stuff. So here is this building. And what he tells us is the roof, the roofing material, weighs 30 pounds per square foot. The rafters underneath the roofing weigh another 3 pounds per square foot. And then there's some other stuff here that we'll worry about next week. Right now, today, we're just going to think about the roof and the rafters. Okay, so that's our situation. And notice under the rafters, we have a front wall here under this end of the rafter. There's a roof beam sitting on some posts in the middle, and then there's a back wall that the other end of the rafter is sitting on. All right. Here is a top view of that roof. I took the roofing off and I'm just showing the rafters. And if you look at a close-up, a detail of those rafters, which you see down here in the lower right corner, I'm showing that those rafters are 2 feet on center. That is, those rafters are 2 feet apart. What does that tell you about the tributary width? If those rafters are 2 feet apart and the tributary area is halfway between one rafter and the next rafter, those tributary widths must be 2 feet wide also, which you see in this isometric view up in the upper right corner. So first, let's think about what we know about how much load is on 1 square foot of roof. Backing up just a minute, what does he tell us? The roof is 30 pounds per square foot. The rafters are 3 pounds per square foot. So what is the total pounds per square foot, roof and rafters? Got to be 33. But let's think about how much load is on 1 linear foot of rafter. So a lineal foot of rafter, you can say linear or lineal. I switch back and forth. A lineal foot of rafter is actually carrying a strip of roof that's 2 feet wide. So the roof carries 33 pounds on every square foot. But if you want to think about linear feet, each rafter is carrying 66 pounds per linear foot, isn't it? 1 square foot is 33. A rafter is carrying 2 of those on every foot of length. So from that, we can now begin to draw a free body diagram for a rafter. And I made a symbol for a distributed load here on top, and I wrote 66 pounds per foot. That's the 66 pounds per lineal foot that is sitting on each rafter. And then I put an arrow for the reaction, one for the front wall, one for the roof beam, one for the back wall. So there's the start of our free body diagram. Now let's figure out how big those reactions are for the wall, the roof beam, and the wall. And to do that, we'll need to think about tributary area. I made an exploded view of this building. That might be helpful and it might be confusing. So if it's confusing, just ignore that. So here is a view of the building And there's our rafter that we're thinking about, and here's our free body diagram. All right, looking down at the top of our roof, now we're going to think about how much weight is on each square foot of roof. Can I back up? I hope I don't make you dizzy here. I'm going to back up to this one. So now we're going to think about how much weight is on each square foot of roof. 33 pounds per square foot. All right. How big an area is that is getting supported by this front wall? What is that tributary area? Well, we know that these rafters are 2 feet apart, and so that tributary area must be 2 feet wide, halfway between one rafter and the next rafter on each side. And how far is it side to side? He gives us these dimensions, and going from left to right, there's a 4-foot overhang. Then from the wall to the roof beam is 14 feet. And then from the roof beam to the back wall is 12 feet. So sorting through all those numbers, what we are interested in here when we're thinking about the front wall is how long is this strip of roofing? Well, we have a 4-foot overhang, and halfway from this wall to the next beam is 7 feet. So this strip here must be 4 feet plus 7 feet. That strip is 11 feet long and it's 2 feet wide. So how many square feet do we have there? We have a rectangle that's 2 feet by 11 feet. We must have 22 square feet of roof. And if we have 22 square feet of roof and every 1 square foot is 33 pounds per square foot, you could say 33 pounds per square foot times 22 square feet. You could figure out how many pounds are sitting on that front wall. How many pounds are sitting on the roof beam? Well, here we were given these dimensions, 14 feet from front wall to roof beam, so half that distance is 7 feet. Then 12 feet from roof beam to back wall, so half that distance is 6 feet. So the length of this tributary area that's sitting on the roof beam must be 7 feet plus 6 feet. That strip must be 13 feet long. And how wide is it? Well, it's another 2-foot wide tributary width because these rafters are 2 feet apart, and halfway from one rafter to the next, gives us a strip that's 2 feet wide. So here we go. Our tributary area is 2 feet times 13 feet. What is that? Must be 26 square feet. And 26 square feet times 33 pounds per square foot will give us how many pounds are sitting on our roof beam. And now the back wall, we've only got half the distance from the roof beam to the back wall. That distance is 12 feet. Half the distance is 6 feet. So this tributary strip is only 6 feet long, and it's 2 feet wide. So what is the area of this tributary width? 6 times 2 is 12. This must be 12 square feet of area. And it's got 33 pounds per foot sitting on every one of those 12 square feet. So 33 times 12 will tell you how much weight is sitting on this back wall. And I got my calculator and calculated 33 pounds per square foot times that front tributary area, 33 pounds per square foot times that middle tributary area, and 33 pounds per square foot times that back tributary area, and I got these three numbers. So here is the free body diagram for the rafter. For one rafter, we have a bazillion rafters. They're all the same. Each rafter looks just the same. It carries this much distributed load on top, and the supports are pushing back with that many pounds of force. Next time, we will come back and we'll work our way down through the walls and the posts and see what's happening.